And that's another type of piecewise function is called a step functions, and it's a group of piecewise functions whose pieces are discontinuous. And they form a series of horizontal steps. One type of step function is called the greatest integer function, or the floor function. And that's signified as f of x is equal to, and then you see these unique little braces here that only have the bottoms, which represents the floor. The greatest integer function, if you see that in an older textbook, it kind of has a double bar brackets, and there wasn't a symbol in there, so make sure you add those little top and bottoms to the brackets. You may see that in older textbooks. And this means the first integer less than or equal to x. So let's take a look at that. If x is 3, what's the first integer less than or equal to x? Well, that's 3, because 3 equals 3. 3.1, what's the integer less than or equal to 3? 0.1, which would be 3. Same for 3.8, would also be 3. But then when we get to 4, the greatest integer less than or equal to 4 is 4. And 4.2 would also be 4. So you're going to see your output is always an integer. So if we would plot that on our graph, let's take a look at a scale. And let's go by 2 so we make this a little bit bigger. So every 2 tick marks is 1. I should say that the other way around. Every tick is a half. Okay, let's use that same scale on the y-axis. Okay, so we said when x is 3, our y value is 3. And we're going to put a closed circle here. And then you can see all the way up until 4, it stays 3. So we're going to put an horizontal line, and at the end of it we're going to put an open circle, because at 4 it jumps up to 4 with a closed circle. And then we're going to have a horizontal line until we reach 5. So there's an open circle there, and then at 5 we would have a filled in circle. So here is the first part of that, but let's continue that pattern, and I'm going to change colors so you can see the difference here. So at 2, we would have a closed circle at 2 and a horizontal line, and then an open circle when we hit 3. And then we can just repeat that pattern all the way along, and if we do it backwards, open circle, horizontal line, close, jump down, open circle, horizontal line, filled in, and we can even continue that into the negatives. And you can see from this picture why they call this the step function. Okay, so if we take a look at our graph, what would f of negative 2.7 equal? Well, that's the floor function, so we could write that this way. And if we look at our graph, here's negative 2, here's negative 3, so negative 2.7 would be approximately here. We go down to our graph and then go over to our y-axis, and we would see that that is at negative 3. Now the floor function has something very similar to it. It's called the ceiling function, and you can see that the brackets change and it only has the bars at the top. So this means the first integer greater than or equal to x. So if we look at 3, that's going to be 3. But 3.1, what's the integer greater to or equal to 3.1? Well, that would be 4. 3.8, again, greater, would go to 4. 4 would equal 4, but 4.2 would go to 5. So if we look at our graph, let's set up the same scale that we had above. Okay, so we would have 3, 3. That would be a closed circle. But when we went past 3, it jumps to 4. So we're going to have an open circle at 4, and then a horizontal line and a closed circle at 4. So what happens when we have a number in the decimals past 2? Well, the greatest integer would be 3, so we're going to have a horizontal line there. And then if we fill in the rest of the function all the way down, at the integers we'd have a closed circle, but then to the left it would be a horizontal line, then an open circle. Okay, so if we use our example that we had above, f of negative 2.7, if we're using the ceiling function, oops. Well, if we look at our graph, here's negative 1, negative 2, negative 3, so negative 2.7 is approximately here, which is going to be hit this line on our graph, which is at negative 2. So the greatest integer less than or equal to negative 2.7 is negative 2.